We are going to go through Chapter 4. Chapter 4 is all about exponential and log functions. So exponential is the first one that we'll be covering in this section. So we're going to evaluate exponential functions, graph them, evaluate functions with base e, and then use compound interest formulas. So our exponential function is f of x equals b raised to the x power, where b has to be a positive constant other than 1, and x is any real number. The exponential function f of x equals 42.2 times 1.56 raised to the x value models the average amount spent, f of x, in dollars at a shopping mall after x hours. What is the average amount spent to the nearest dollar after 3 hours at a shopping mall? So it's asking for 3 hours. After 3 hours, what is the amount spent? So that means we are going to plug in a 3 for the x value. And we do have a calculator we can use. And so it says to the nearest dollar. So f of 3 will be $160. So what is the average amount spent after 3 hours? The average amount spent is $160. Okay. When graphing exponential functions, we are going to graph first by hand without using the calculator, and then we can look at it in the calculator. So f of x is 3 raised to the x value. We're going to set up a table of coordinates, then plot these points and connect them with a smooth, continuous curve. So f of negative 2 is 3 to the negative 2, which, using our law of exponents, we know that if you have a negative power, you move it to the denominator. So 1 over 3 squared, which would be 1/9, which would be, what is 1/9 as a decimal? Y'all remember? 0.1 repeating. So negative 2 is at 0.1. So I'm just going to put a little dot where I think it is. Negative 2 and then up to 0.1. Now we're going to use negative 1 for x. Three raised to the negative 1 is 1/3. Because we move it to the bottom, change the exponent to a positive. And we know that is 0.3 repeating. So negative 1 and 0.3. F to the 0 power, or f of 0, sorry. So that'd be 3 raised to the 0 power. What is anything to the 0 power?
0.
What? 1. This is a good review, right? Good review. So there we go. All right, what about f of 1? Quiet down, please. Just 3. Yep, 3 to the first power, which is just 3. So let's go ahead and connect these with a smooth, continuous curve. Where will the next one be? F2? That would be like 3 squared, which is 9. So we know we're not going to pass that, so we'll do it like that. And this approaches 0, but never touches. So that's an asymptote at y equals 0. Okay, so with exponential functions, we can look at our characteristics. The domain is negative infinity to positive infinity. And then the range is 0 to infinity. The graphs they pass through point 0, 1 because b to the 0 equals 1. So we have a y-intercept of 1. There is no x-intercept because it doesn't cross the x-axis. The function f of x equals b to the x has a graph that goes up to the right and is an increasing function. So we know it's going to be like that. And it could also be like that. Those are examples of what it's going to look like. So it says the greater the value of b, the steeper the increase. Just like with slope and linear equations, if the slope is bigger, it's going to be steeper. If it is smaller than 1, it's going to be less steep. So it's the same type. Okay, if we have the b value is between 0 and 1, so let's say it's a decimal or a fraction between 0 and 1, has a graph that goes down to the right and is a decreasing function. So it's going to be like this. F of x equals bx. B raised to the x is a 1-to-1 function and has an inverse that is also a function. And it has the horizontal asymptote of y equals 0. So the different types of transformations are, if you do plus or minus a number, that's going to shift or translate it up or down. If the plus or minus is in the exponent, it's going to go left or right. If you have negative out front of the b, it's going to reflect across the x-axis. If the x is a negative, it's going to reflect about the y-axis. A vertical stretch or shrink is found by a number being multiplied by b. That's a vertical stretch or a shrink. You can also call it compression. And then horizontal stretch or shrink is found by a value being multiplied times x. It's horizontal stretch or shrink. So let's look at f of x equals 3 raised to the x and f of x equals 3 raised to the x minus 1. So let's look back at the transformations. So what's being changed on here is horizontal transformation. So it says plus or minus. It says minus 1. Minus 1 means it's going to shift right c units. So this is going to shift right 1 unit. But let's go ahead and graph them. So we know what the first one was. It was like here, here, and then 1, and then 3. So this was our same one, the f of x equals 3 raised to the x value. So now with a different color, I'm going to graph the other one. So let's start with -2. Because the first one started with -2 and it was like 0.111. So I'm going to use my calculator to find what 3 raised to the -2 minus 1. So that's 3 raised to the -3, 0.037. 0.037. So that's a little bit lower, right? Okay, let's do -1. I'm going to use the same thing. Change the -2 to a -1. So it's 0.1 repeating. Zero. Just going to change this to 0 minus 1. 0.3 repeating. And then 1. 3 raised to the 1 minus 1, which is 3 to the 0, which is 1. 2. 3 raised to the 2 minus 1, 3, and so on. So if you compare these, see how -1 is at 0.1, but here is -2. -1 is at 0.3, but 0.3 is here. So they have the same numbers, it's just shifted. So it has the same steepness. So we'll start with 1, 1, 1, 1, 2, 3, 0.3, and then it's kind of like that. So it has the same steepness. It is just shifted right 1 unit. Okay, the natural base E. It's defined as 1 plus 1 over n raised to the nth power. It approaches that number as n gets larger and larger. As n goes to infinity, the approximate value of E is 9 decimal places, which it's written right there. E is approximately 2.72 is what I usually use. So approximately 2.72. It's called natural base. It's the natural exponential function. F of x equals e raised to an x value. So that's your exponential function. The exponential function is modeled right there. It models the gray wolf population of the Western Great Lakes, f of x years after 1978. Project the gray wolf's population in the recovery area in 2014. So it says X years after 1978. So we need to find out how many years after 1978 2014 is. So how do we find what our X value is?
2014 months.
Mm-hmm. So 36 years after 1978. So we need to find out the population. So we are doing f of 36 is 1,144. E raised to the 0.0325 times 36. Yep, we can just type that into the calculator. Do you know where E is? It's right here. So we need to use second and then the ln, which is natural log, raised to the 0.0325 times 36.
460. I got 3,685. Oh, I put 144.
Oh. So we're talking about population. So how should we?
People. So you should round to the
Lower one.
upper one. The one above it.
Because it's 0.9595, but that's not a full
So you have to ask.
wolf. Wouldn't you go down one?
Yes, you go down.
Yeah, you'd go down.
0.9 of a person is not a whole person.
Right.
So you can't go up.
It still counts as a person, though. Yeah.
It's gone. Just missing.
What if they're missing a leg?
They wouldn't factor that in.
Like, if you're talking about people, you always go down.
Yep.
You always go up.
No.
That's childish.
You can't have points anything but person.
Right. Katie's right.
Yeah, Katie's right.
All right, let's keep on going. So where you will see these types of equations is with compound interest. Do y'all remember I taught this back in 7th grade? And we did not have a calculator in 7th grade. So they made these kind of simple, like with 1s and 2s. But we still had to do these type of problems. So it's back again. But thankfully we have a calculator this time. So let's talk about what each letter means. So T is years. The balance A in an account with P principal, annual interest rate R in decimal form. So let's look at our first example. It says the sum of $10,000 is invested at an annual rate of 1.08%. Find the balance in the account after 5 years, subject to compounding quarterly. So that's where in comes in. It says in compounding periods. So if it's compounded quarterly, then what is in? Huh? So how many times, if it's
4.
within 1 year, how many times would you compound it? 4 times. Because you'd break up a year into quarters. Yep. Okay, what is the years? What is T? 5. What is P for principal? 10,000. And then what is our rate, R? It's written as a percent, but we're supposed to write it as a decimal. So how do we convert that to a decimal? Yeah, 2, 1, 2. So 0.0108. And this is compounded quarterly, so we're going to use formula number 1. It's not compounded continuously. It's just quarterly. So A equals P, so 10,000, 1 plus R over N raised to the N times T. So put that in your calculator.
Is that really low?
I got 10,000.
I got 10,122.
I got 2,550. That's what I
Uh,
got.
Where did I go wrong?
That's what I got.
What's the answer?
Did y'all do 4 times 5?
Oh, I thought it was
4.5.
No, it's 4 times 5.
4 times 5, yeah, so it's 20. That should be 20 right there.
I would never.
Y'all are all-
If you want to, you can just put 20 there.
y'all are all dumb.
Hey. Yeah, I got 2,000 covered.
I never get it wrong.
All right, so our account balance is approximately 10,554.08. Do y'all agree?
Yes.
Okay. Okay, what if it is compounded continuously?
You divide.
We'll just do 1.
We use formula number 2,
Oh,
continuous compounding. So formula number 2. Yep. So A equals 10,000 times E to the R times T, so T is 5 years.
What is E?
E is your exponential natural base is what it's called. We're going to get into it further Tuesday and Wednesday. Oh, I missed a 0. Yeah, let me change it.
You have to actually put the times. You can't just put the E.
The decimals are different. So they're not.
There we go. Is that right? Okay.
You don't have to put the time. I would just put the E.
yeah, why can't you put the E?
Oh, yeah, I got it right. Never mind. You can. You don't
Can't,
have to put the
you don't have to put the times? Okay.
Just a whole bunch of- Such a pretty-
A is approximately 10,000. Why don't we do a squiggly?
Oh, we should have. Yep. All right.